Hey, this is McGraw-Hill Chapter 5, Section 2, Multiplying and Dividing Rational Expressions. Remember that rational expressions are nothing more than fractions with variables. So the same rules that we use to multiply and divide fractions is the same rules we use to multiply and divide rational expressions. Most important part to these problems is the factoring. So if you look at example 1, page 432, you see 5a minus 5b over 10 times 2 over a squared minus b squared. Well, the first thing we notice is that 5a minus 5b, we can greatest common factor out of 5. Second thing we notice is that with a squared minus b squared, we can make, it's a difference of squares, so we can make a minus b times a plus b. We then notice that 5 times 2 is 10. 10 divided by 10 becomes 1. A minus b over a minus b becomes 1. So we end up with a 1 on top, a plus b. Because a plus b is in the denominator's place of a fraction, it needs to stay there. Because everything cancels out on top, it's not 0, it's 1. So now we have 1 over a plus b. Coming down here to example 2, a little more involved here. Same thing though, it's multiplication. First thing we notice is that 4w minus 20p, we can factor a 4 out. 2w squared plus 7wp minus 15p squared is a trinomial. It factors into 2w minus 3p times w minus plus 5p. Come down to the bottom here. We first greatest common factor out of 2. That's going to make it w squared minus 25p squared, which becomes the difference of squares, which is w minus p 5p times w plus 5p. Factor out of 3 here, so we get 3 times w plus 3p. If we look at what we got, the 4 on top divided by the 2 makes it 2 on the top. We have a 3 left on the bottom. 5 minus 5p, 5 minus p becomes 1. w plus 5p, w plus 5p becomes 1. So then we have 2w minus 3p on top, w plus 3p on the bottom. So our final answer becomes 2 times 2w minus 3p on top, 3 times w plus 3p on the bottom. Again, factoring is the most important part here. Once you factor, all you got to do is look to see if you have the same thing top and bottom, and basically they become 1, which means they're gone. Last example problem here is example 3, page 434. It's division. Remember that in division of fractions, we don't ever actually divide fractions because we always multiply by the reciprocal. So a division problem for rational expressions becomes a multiplication problem. Same thing as in fractions. So what's going to happen is we have this 8t cubed plus 27 over 9 minus 4t squared divided by 4t squared minus 6t plus 9 over 2t squared minus t minus 3. My suggestion is to go ahead and flip or write the reciprocal of the second one right off the bat. So that's what I did. See how the front rational expression stayed the same, but I wrote the reciprocal of the back, and now it becomes a multiplication problem. Now again, most important part of the problem becomes factoring. So this is a sum of cubes, so it becomes 2t plus 3 times 4t squared plus 6t plus 9. Make sure you understand that in difference and sum of cubes, that this trinomial here is non-factorable. Whenever you factor a difference or sum of cubes, the trinomial you factor it into is non-factorable. The bottom I multiply by a negative, so it became 4t squared minus 9, which is a difference of squares, so it becomes 2t minus 3 times 2t plus 3. I forgot to write the plus sign. You come over here, this 2t squared minus t minus 3 becomes 2t plus 3, 2t minus 3 times t plus 1. The bottom one, 4t squared minus 6t plus 9 is non-factorable, so it stays the same. If you look at what happens here, now let's go and cancel out. So 2t plus 3 cancels out with 2t plus 3. 2t minus 3 cancels out with 2t minus 3. 4t squared plus 6t plus 9 cancels out with 4t squared minus or plus 6t plus 9. It's another plus. Oh, it's a minus. This is a minus. So this becomes a minus. Okay. And so now what happens is we have left with t plus 1 on top, and then we still have this minus sign, which we're going to make minus 1. So you could leave it like this, or you could realize that if you divide this, it becomes minus t plus 1. You could still write it as 1 minus t. I would prefer you leave it in factored form. Okay? So that's it for this section.